Different types of linear programming problems. Manufacturing problems. In these problems, we determine the number of units of different products which should be produced and sold by a firm when each product requires a fixed manpower, machine hours, labor hour per unit of product, warehouse space per unit of the output, etc. in order to make maximum profit. Let's take an example to understand it better. Example. A factory manufactures two types of screws, A and B. Each type of screw requires the use of two machines, an automatic and a hand-operated. It takes 4 minutes on the automatic and 6 minutes on hand-operated machines to manufacture a package of screws A, while it takes 6 minutes on automatic and 3 minutes on the hand-operated machines to manufacture a package of screws B. Each machine is available for at the most 4 hours on any day. The manufacturer can sell a package of screws A at a profit of Rs 7 and screws B at a profit of Rs 10. Assuming that he can sell all the screws he manufactures, how many packages of each type should the factory owner produce in a day in order to maximize his profit? Determine the maximum profit. Solution. Let the factory manufacture X screws of type A and Y screws of type B on each day. Therefore, X is greater than or equal to 0 and Y is greater than or equal to 0. The given information can be compiled in a table as follows. The profit on a package of screws A is Rs 7 and on the package of screws B is Rs 10. Therefore, the constraints are 4x plus 6y is smaller than or equal to 240. 6x plus 3y is smaller than or equal to 240. Total profit Z is equal to 7x plus 10y. The mathematical formulation of the given problem is maximize Z equals 7x plus 10y, mark it as equation 1, subject to the constraints. 4x plus 6y is smaller than or equal to 240, mark it as equation 2. 6x plus 3y is smaller than or equal to 240, mark it as equation 3. xy is greater than or equal to 0. 4. The feasible region determined by the system of constraints is given as the corner points are A 40, 0, B 30, 20 and C 0, 40. The values of Z at these corner points are as follows. The maximum value of Z is 410 at 30, 20. Thus, the factory should produce 30 packages of screws A and 20 packages of screws B to get the maximum profit of Rs 410. Diet problems. In these problems, we determine the amount of different kinds of constituents or nutrients which should be included in a diet so as to minimize the cost of the desired diet such that it contains a certain minimum amount of each constituent nutrients. Example. Reshma wishes to mix two types of food, P and Q, in such a way that the vitamin contents of the mixture contain at least 8 units of vitamin A and 11 units of vitamin B. Food P costs Rs 60 per kg and food Q costs Rs 80 per kg. Food P contains 3 units per kg of vitamin A and 5 units per kg of vitamin B, while food Q contains 4 units per kg of vitamin A and 2 units per kg of vitamin B. Determine the minimum cost of the mixture. Solution. Let the mixture contain X kg of food P and Y kg of food Q. Therefore, X is greater than or equal to 0 and Y is greater than or equal to 0. The given information can be compiled in a table as follows. The mixture must contain at least 8 units of vitamin A and 11 units of vitamin B. Therefore, the constraints are 3x plus 4y is greater than or equal to 8. 5x plus 2y is greater than or equal to 11. Total cost Z of purchasing food is Z equals 60x plus 80y. The mathematical formulation of the given problem is minimize Z equals 60x plus 80y. Mark it as equation 1. Subject to the constraints. 3x plus 4y is greater than or equal to 8. Mark it as equation 2. 5x plus 2y is greater than or equal to 11. Mark it as equation 3. xy is greater than or equal to 0. Mark it as equation 4. The feasible region determined by the system of constraints is as follows. It can be seen that the feasible region is unbounded. The corner points of the feasible region are A. 8 upon 3, 0, B. 2, 1 upon 2, and C. 0, 11 upon 2. The values of Z at these corner points are as follows. As the feasible region is unbounded, therefore, 160 may or may not be the minimum value of Z. For this, we graph the inequality 60x plus 80y is smaller than 160 or 3x plus 4y is smaller than 8 and check whether the resulting half plane has points in common with the feasible region or not. It can be seen that the feasible region has no common point with 3x plus 4y smaller than 8. Therefore, the minimum cost of the mixture will be Rs 160 at the line segment joining the points 8 upon 3, 0 and 2, 1 upon 2.